So this one, well, we're not going to need it quite yet, but in the next example, so just make sure you find them. It says, find a polynomial function that models this data. So when you have a table of data, you are going to do the finite difference method. So we're going to do D1. So you take 2 minus -1, that's 3. 7 minus 2 is 5. 14 minus 7 is 7. 23 minus 14 is 9. 34 minus 23 is 11. And 47 minus 34 is 13. So it's not linear. Let's do the second differences. Oh, this one's pretty quick. So my degree is the second degree, or 2. So step 1, if you want to find a polynomial function, you do the finite differences to figure out what the degree of the polynomial is. Step 2, write the general form. For quadratics, the general form is ax squared plus bx plus c. From the table, you need to pick points. How many points do you need? The number of points is equal to the degree plus 1. And I'll explain why in a moment. So step 3, make sure you write this down. This is a critical piece that's going to help you when we do other ones. So all we need to do then, if this is quadratic, how many points do I need? 3. So I find, let's pick the first, let's do the first 3. And again, you could pick any 3 in the table, okay? So we have, these are x and y values, right? And we're trying to find the a, b, and c values. So I'm going to make a beautiful connection to that worksheet after the quiz and what we did in our very first unit. Watch what we're going to do. I'm going to plug in x and y into the general equation to create a system of equations. So here's what we're doing. We're trying to find the a, the b, and the c in y equals ax squared plus bx plus c. Well, I have a bunch of x and y values, so what I'm doing is I'm going to plug in x and y into this general equation, and I'm going to do it 3 times. So watch this. This is really, really cool. So I'm going to write -1 equals a times 0 squared plus 0, wrong letter, b times 0 plus c. Ooh, isn't that c is -1? I already got the c value, okay. Now we're going to take the second point. 2 equals a times 1 squared plus b times 1 plus c. But don't we know the c value now? So that's 2 equals a plus b minus 1. So A plus B equals 3. We're going to put a box around it. Now I'm going to take the third point. I'm going to plug in the x and the y. And don't we know C is -1? So let's take care of that. So again, in case I've lost you, we'll go over it again. I'm taking 0, -1, and I plugged it into the general quadratic form. Then I did 2 comma, the 2 for the y, the x for the 1, plugged it in. Now I'm doing it with my third point. I'm plugging in that y is 7, x is 2 in this general form. Yeah. Okay, these all go together, right? This is all on the same parabola. So do you see this with C is -1? Like the first equation gave it to me. Do you see how C was -1? So then, once I have C, I plug it in. That's all I'm doing. So then I'm going to add the 1 and get 8 equals 4A plus 2B. Now, sometimes I don't know the C value, and then I'm going to get a 3 by 3 system. Which, remember, I had you do that as a spiral review. So I have 3 equals A plus B. And then do you remember what I told you about common factors? Couldn't I divide that by 2? I'm going to divide by 2 to make my life easier. I'm going to pause a moment and give you about a 1-minute head start. Solve this system. The 3 equals A plus B, 4 equals 2A plus B. So do what you need to do to find one of the letters, then back substitute it. All right, can somebody help us? What should I do? Yeah, Angelo? You multiply by -2? Cool. So -6 equals -2A minus 2B. So you got -2 equals -B. So you got B is 2, right? Was not the only way to do that. I probably would have multiplied by -1 and got rid of my B, but no biggie. That does the job. All right, now I'm going to go back to the A plus B equals 3 and plug in that B is 2. So what's A? 1. So now, A is 1, B was 2, C was -1. So what we're going to do is we're going to use the general form to now write this equation. So this would be y equals x squared plus 2x minus 1. So what's really neat is this equation, the points go through it. Okay? All of them actually go through that. All right, questions on that? Again, if this had been where C was not known initially, I would have had 3 equations with A, B, C, and I'd have to go through the process of eliminating one letter, then getting it down to the 2 by 2, and then go from there. The good news is we're going to learn how to use our graphing calculators again in a different way. Earlier we did matrices. We're also going to look at when we collect data. Sometimes all the data points don't go through every point and you're approximating the model. And that's more real world. That's what actually happens. All right, so go to Canvas, and I want you to grab two things for me and put in Notability. I want you to get the day 2 notes, and then there's something there called the 6-1 instructions and video links for regression equations on the graphing calculator. I'm going to show the TI Nspire. Those of you with the 84s, you can follow the instruction sheet. I gave you step by step, and if I lose you, there's a video on how to do it. But have both of those available. So I'll talk you through it as best I can, yeah. If you go to Canvas, into our module for this week, today is Wednesday, just roll there. Yeah, there's a link. Alright, so in our introduction to polynomials, we use the finite differences method to determine the degree of the polynomial. We can also solve a 3x3 system or a 2x2 system so when you're doing a quadratic. In this lesson, we're going to use a scatter plot and regression tools on our graphing calculator to find the best equation to model the data. So in this lesson, and those of you with the TI Nspire, pull up the instruction sheet as well, because if I lose you, you see the step-by-steps what you need. So here's number 1. The table shows the population of a town from 1996 to 2004. Assume T is the number of years since 1996, and P is measured in thousands of people. So let's pause a moment and let's make sure we understand our table. So if the year T is 0, what year is that? 1996. And if I have 8, what year is that? 2004, right? Because it's 8 years since 1996. Now, if I have 22.8 for the population, how many people is it actually? It's not 22.8 people. What's P? What are the units of P? Thousands. So what is 22.8? What is the actual population then? 22,800. Does that make sense? And so if I go to year 2004, 26.1, what's the population then? 26,100. Does that make sense? So when you're given a table of information, you do want to pause and think about what is represented, okay? So in letter A, it says we want to use a graphing calculator to find the best fitting quadratic model. So I would like you to use your highlighter, and it says quadratic, so it's already telling me which type. I didn't have to go do a finite differences to figure that out. So I'm going to pull up my graphing calculator, and those of you with your TI 84s, let me stop this share. All right, can you see that? Okay, so TI 84, or excuse me, Nspires, let me get out of here, and I will. So you're going to open a new document. And then here's what you do. You're going to tap Document, Doc. Ah, I did a new doc, sorry. And we're going to do number 4. Add lists and spreadsheet. So those of you with the TI 84, you're going to follow your own sheet, because I don't have that to share. So I do number 4, and it's going to bring up a screen like this. If you don't have a graphing calculator, I have 2 or 3 back there. You can go borrow one of mine and go pop your cell phone in. I've got at least 2 back there. Just make sure it says McInerney on the back. you're going to go up to the tippy top, and we're going to put the variable x, and we're going to put the variable y in the tippy top columns. And then what you do is the x column is always that top row of your data, or the independent variable. You put nothing in the row that has the equal sign, okay? And if I lose you on the TI Nspires, that's where you go to the instruction sheet. And what we're going to do is you're going to enter your data. So I'm going to put the 0, 1, 2, 3, 4, 5, 6, 7, 8. Then in your Y column, you're going to put that data, which is 22.8, 25, 26.5, 27.1, 27.8, 28.1, 27.9, 26.9, and 26.1. All right, those of you with the TI-84s, you just press Stat, Enter, clear any data, and then in L1 you put your X values, and in LT you put your Y values. Then you press Window and keep following your directions there. All right, then on the I'm using the TI Nspire instruction sheet. Now we're all going to press Control I. And you are going to insert a new screen, and you are going to add data and statistics. Ooh, look at that, it's pretty. So it plots it for us. So I did Control I, and you should see this. Down here at the bottom, you're going to click where it says click to add a variable, and you're going to label it your x-axis, and this one is your y-axis. Oh, look how pretty. That looks like a parabola that's opening down. Talk to each other, okay? Talk to each other if you're getting lost or stuck. Where are the TI-84s? Anybody else with the TI-84? Because you should probably sit together and help each other. Anybody else? Only one? Okay. You doing okay? All right. So when we're done, I'll help you, but there's also a video on how to do it too. Okay. So now, do you see that this does look like a parabola? So quadratic was a good option. Now we're going to click Menu. Number 4 is Analyze. Okay, you press on the TI Nspire, you press Menu, Analyze, Regression. And this, you have to know which kind you have. This is quadratic. And there's the equation. Yay. So, and we can round maybe, let's see how far I rounded. I only rounded 2 decimals, and I'll put this in the notes when I pull it back up. But we have something called an R value, and the R value tells you how good the approximation is. If the number is close to 1 or -1, then it's a really good approximation. So here's how you find the R value. You're going to do Control I again to get a new screen. And you want to do Calculator. Okay, Control I, pull up Calculator. And then you do Menu. Number 6 is Statistics, Stat Calculations. And then you do have to type in your X and your Y, and that's it. And you say OK. And so, whoops. Yeah. Menu number 6. And then we want number 1, stat calculations. And then I want quadratic regression. And then you do have to put that that's X and Y. And you don't need to put anything in any of the other categories. Then for some reason mine's not showing. Am I hitting the wrong button? This would be quadratic regression. There it is. Okay, I must have been hitting the wrong button. So do you see that R squared is 0.99? That means it's excellent. That means that is an excellent approximation. So let me come back up here to my Zoom and pull this back up, and then I'll write all this out for those of you that weren't quite getting that. Oops. There we go. Okay, perfect. There it is. Okay, so let me write this in, what we just determined. So here was the regression. We got negative 0.21 t squared plus 2.08 t plus 22.96. R squared was 0.99, which is excellent. It says, using the model you found, find the anticipated population in 2010. So what is T? I'm not going to put 2010 in. Yeah, Jordan? Yeah, how'd you get 14? Yeah, it's since 1996, so you take your 2010 minus 1996, which is 14. All right, so let me give you a moment to calculate it. Oh, you did fantastic there, Ruth, by yourself. All right, anybody have an answer for P? 10.92. Now, if this were a test question, we wouldn't put 10.92 because P is in thousands of people. So we would say the population was and now we're estimating, right? Approximately 10,920 people. All right, let's do it again. Okay, so if I lost you on the first one, we're going to do it again. Number 2 says the table shows the operating costs of a small store from 2000 to 2005. Assume that T is the number of years since 2000 and C is the cost in thousands of dollars. This says, let's find the best fitting quadratic model for the data. So I don't have to guess what it is. So let's go through the process again. So let me stop sharing and pull up my screen. All right, so we're going to start a new document. So let's do a new one. Not saving that stuff. Okay, so you start a new document and you do number 4, lists and spreadsheets. Okay, so I want everybody, hopefully you're with me. So you're starting a new document. Then you press number 4, add lists and spreadsheets. Go to the tippy top and call it X and the next column Y. Again, go to the tippy top, call it X, and call it Y. Now we're going to enter the data. Our X column would be 0, 1, 3, 5. My Y column is going to represent the operating costs in thousands, so it's 14.8, 9.1, 3.3, 5.1. Anybody need help? Now, because we know it's quadratic, we don't necessarily have to make the scatter plot. Okay, you don't necessarily have to do the scatter plot again. So watch what we could do. We can do Control I, kind of stay with me here, Control I, and I'm going to just go directly to add data. Oh, there, it just did it again. Okay, that's fine. So we'll do it again. There's X and there's Y. Oh, nice. Look, can you see? It's like part of the parabola. Can you give me thumbs up? How many of you are with me? Are you still with me? All right, good. So now we're going to press Menu, Analyze, Regression, Quadratic Regression. There it is. Cool beans. And then I want to see, so I'm going to do Control I again. Nope, that wasn't what I wanted. Oh, I wanted the calculator screen. Sorry. So I want calculator, sorry. And now do Menu, Statistics, Stat Calculations. And I wanted number 6. Just put your X and Y in. Ooh, 0.999995. That's outstanding. That is excellent. Okay, so I'm going to go share that and pop it back in. Again, I have all of this on the instructions sheet, and I have a video that takes you through it. So I see most of you do have your graphing calculators, which is awesome. So here's my quadratic. It would be C, because they're using C. I would never mark it wrong if you use X and Y. That's okay. I'm getting 0.95 t squared minus 6.67 t plus 14.81. My r squared was 0.999995, which was excellent. Then it says, use the model to find the lowest operating cost. Do you understand that this was a parabola that opens up? Where are you going to find the lowest operating cost? Where is it located? At the vertex, right? So let me show you on your graphing calculators how to find the vertex from the graph. Or you could do it x equals negative b over 2a, right? But I would like to show you how we can use the graphing calculators now to do this. Okay, so let me stop sharing and go back to that calculator graph. There it is. So watch this. I can add a graph. I'm not going to save that. So watch this. You can and you can do this on either type of calculator. Go to add a graph and let me show you this. I'm going to put 0.95 x squared minus 6.67x plus the 14.81. Okay, so this is on just a standard window. And let me show you how the graphing calculator will find a vertex for you. This is why I didn't let you use the graphing calculators in Unit 5, because I knew some of you would figure it out. You go to Menu. Okay, once you have your parabola in and graphed, you type Menu, Analyze, and then on this one, it's the minimum, right? So you just take this dashed line and put it a little bit left and a little bit to the right so that the minimum's there. And I'm getting 3.51 and 3.1. And on yours, Angelo, on the TI-84, you can press second, and it might be the trace button that says calc, and then it'll say minimum, maximum there. Do you see it? Once you're on your graph, you press second, and it's the fourth one at the top. I think it says second, and you can do calc. You see that? Then one of your options is minimum, maximums, and zeros. Yeah, it's the minimum. Okay, so now let's jot this down, and this is perfect because this was as far as I wanted to go today. So let's finish writing and answering this piece. So if I wanted to know the lowest operating cost, it happens at my vertex, which was 3.5 and 3.1. So let's answer the question though. The lowest operating cost from 2000 to 2005 is about, remember this is in thousands, $3,100 after 3.5 years.